Good evening, everyone. Hope y'all are having a good night. Back for another night of game development stuff. So today we're gonna do some more 2D planner stuff. Last time we got all the animation stuff working to where you can move around. And then I started down the path of creating the data structure to model the nodes in a particular planning space. And then from that, I'm basically going to use that to be able to plan with the Dijkstra algorithm. So I think last time I was correctly marking all of the ones that are obstacles as obstacles, and that was pretty much where I stopped. So going to continue from there. I think the other piece missing is the fact that each node doesn't have a reference to its adjacent node or adjacent nodes. So that's part of that process. So going to try to knock that out today, but we will see. What else is there? Yeah, so sorry for not streaming yesterday. It's Memorial Day. Hope y'all had a great Memorial Day. Ate some good food, celebrated the, thankful for everybody that, have given their lives for us to be able to do what we do every single day. So yeah, so let's go ahead and get into it. Let me switch on over real quick. Alrighty. I also did a little bit of digging. Actually, was it digging? I think I read so I'm in a Unity group on Facebook, like Unity developer group on Facebook. And one of the things that came up on there, somebody ran into the same ridiculousness that I did when they started doing animation, state machine stuff. They essentially ended with every state can go to any other state. So apparently there's two options to do that better. One is blended animations, and then another like blended trees, and then there's another one of doing like subtrees. So that's what I found out. May do a little bit of digging to see if we can optimize a little bit on that to be able to make it a little easier. So yeah, we'll go from there, but that's just something to keep in mind. I think it's blend trees. So transitions are used for transition smoothly from one animation state to another over a given amount of time, while blend trees are used for allowing multiple animations to be blended smoothly by incorporating parts of them all to varying degrees. The amount of each motion is contributed to the... I don't know if that really is... Is that really what we want? It's a sub-state machine. Interesting. Yeah, so I'll have to go through this and see what the best solution to our problem is. But ultimately, what we have done with the animation state machine where any state can go to any other state is not exactly ideal. So there's apparently a better way to do it, and people have ideas. So yeah, so where we're at right now, let's fix something real quick. There we go. The only downside is when you change directions. They like stay animating in the direction they were moving previously for a little bit of time. Okay, so let's see what the script. So we have this. That's not what I want. Let's just do open up node. Okay, so the parent node is only used for actually planning a path when we go to try to actually do a path from point A to point B. We set that parent node when we identify the lowest cost node to go to from a previous node, and then we just keep transforming along that particular node. So, but this list of neighbor nodes needs to be initialized. So really what this needs to be is a list of nodes. So ideally we track when we visited a node so we don't revisit another node, and that's very important when you're searching, because if you've already visited, then you don't want to visit it again, because you can get stuck in a loop and stuff. So I was thinking about potentially adding a flag in here. So set parent node, set wait, set obstacle. This is interesting. Happens when you yoink some code off the internets. Okay. So I believe we initialize this node here. The way we can add neighbor nodes is basically doing like subtracting. Let's go ahead and do this. Let's see. It should be an int, yeah. Yeah. I always hate when I call them X and Y. Should be max. Better to refer to them as, like, you know, rows and columns. But it's okay. I'm pulling these out so that I can easily check them later when I add. Basically, I get the bounding or get neighbor node locations. So what we can do is get the list of nodes, get neighbor nodes. Sorry, do neighbor. Okay. And do I get, I don't think, did I get, okay, so I did put the grid location. So the grid location, we would essentially want to, and then we can look up. Let's do. So what that is, actually that. Yeah, that's unfortunate. So I extracted these out and then I can't even use them. I mean, I guess I could pass them in, but it's like, at that point, really, what's it buying you? So I'm gonna take these out. But, let's do this. I'll need them here. Okay, so I'm gonna take, I'm gonna get the, can I just cast this to a vector2 int? Node location equals. See if it's okay with me doing that. Probably not. Oh, you can do that? Okay. 3. Okay. And then there's basically going to be the best way to do this that's not hideous as hell. Yeah, so basically we need to just check, you know, plus, like, add 1x, add 1y, add, subtract 1y, subtract 1x. And you gotta check we basically check this for locations, and, but we also have to check to see if they're at the max. It's a good way to generalize this. Could create a function that just checks it if it's out of bounds, whether it's less than or equal to 0 or greater than or equal to max x, y, or y. And we always generate the 4 points and we throw it into there, and if it's not valid, then we don't add the node. All right, here's what I'm thinking. Let's do this. Let's have a private function returns a node, maybe. That looks up the node based on a provided vector2 int. We'll do vector3 int. So I think technically it's the Wazie's location is 1 or some garbage like that. Okay, so then what we can do here is just say what the hell? I want to know what it thinks I should do here. That was a name violation? What the? What? That wasn't even what I wanted it to fix. Okay, whatever. Yeah, so you can just say if why did I do that to myself? I almost made a stupid mistake there. Get length. I'm just checking to see if checking for out of bounds. Why is this thing so mad at me? Oh, yeah. Please stop complaining. Okay, check to see if it's out of bounds. If it is, then return no neighbor node, which is fine. Otherwise, we return. Guess we can just do nodes, location.x, location.y. I wasted my time typing that other thing. The only tricky part is we actually have to do that after. Can you turn a reference? Is it okay doing that? You turn a reference? Yeah, you can. How do you return a reference to a null? C# return ref null. It's probably some stupid like fancy thing you gotta do. Hmm? That's not what I asked. Do. I think it does it by default. That's why I don't know if I need this or not. Is that okay? No. All right, we're gonna try it without it, but I'm just saying it right now so that later on, when I'm streaming this and I run into this problem, I'm gonna say, "I told you so, Luke. You ran into this stupid problem because you didn't take care of this earlier." That I have a feeling I'm accidentally going to create dupes of items or the nodes and put them in the list of adjacent nodes, and then I'm going to mark them as visited, and it won't affect the original one, and we're going to revisit all kinds of freaking duplicated nodes throughout our tree. I'm going to go ahead and call that right now because it's probably going to happen. So there. But the reason I'm not doing it because I have a feeling objects are passed by reference in C#. By default, it doesn't make a copy of the object. I don't know. It's hard. It's hard to say. I'm going to pass this nodes by reference for sure, though. Not sure we even really did. Like, we're passing this in. We're just like kidding ourselves because it's private to this function. So does it really matter? Probably not. But you know, it's all good. Okay, so this basically we're gonna be building a list of neighbors, and then so can you like clone one? All right, here's what I'm gonna do. This is, let me see if I can get away with this. Oh, I can. All right, y'all ready for this? This is gonna be good shit. All right, so I think what we can do is look up the node, and we take the node location and we add vector3 int left. That should be a unit vector of 1, -1. So I think that'll work. Why is it not happy about this? Like, all right, well, we'll get to that. Right, up, down. So one little caveat thing here, I don't think I can do this in this loop. I think I have to build all the nodes, then I have to go back through the nodes and add the neighbors, because I will not have, like, for example, the very first node that I create, there won't be neighbors to even look up, so it's going to blow up. So I have to wait for them to all be created and then populate the neighbors. So if left Okay. Yeah, so if it's not equal to null, then you just add it. This is boilerplate garbage that I could get rid of too, but let's just make sure that this works first before I do any excessive optimizations. Okay, so this should look up the nodes and all that good stuff. So what I'm actually gonna do is I'm gonna look it up and then look up the neighbors and set neighbors, add neighbors. Yeah, that's unfortunate. Why is it not happy with me saying nodes? What the hell are you talking about, bro? Wow. I'm gonna add that, which is add neighbor nodes. Adding a single node is no good. Can I do that? Yes. Okay, so do a little sanity check here. Oh, yeah, that would be hilarious. Return neighbors. Alright, so we're gonna do a little bit of a sanity check. Make sure this. Okay. So first things first, it'll populate the nodes. So nodes should be huge, right? So now we just need to check, sanity check here, right? So wait a second. Neighbor code be broke. The grid locations actually, it's not the zero based location. It's the 0, 0 is the center and you're on the outer bounds, which means my check here is not good. Because if I had to guess, we'll just entertain this idea here. So what we're gonna get is the node that we found was -37, -23. So the max is 74. Yeah. I have to convert that to local. So this should be local. So no. Let me. So local is actually. I need to get local from world. Which I believe adds. It should add, yeah. Okay, let's try this again. All right, so now max X, max Y. Its node location is 001, which is what I would expect. Left, I should get nothing. Right, I should get something. Ba-ba-ba-ba-ba. It's a new node? No, it's... Oh yeah, it is new node. Yeah. Alright, that seems right. So I should get a right and a down. Just kidding. Right and up. Because of the fact that we're in the bottom left-hand corner. I was thinking top left. Okay, so node, it now has two neighbors. So let's just double check here. If we go to these nodes here, it says two neighbors. All right, this seems like it'll work. We just... I think it was reloading. Okay, that one has 3, that seems right. Okay. This logic seems right to me. Alright, so I think we've got a decent grid being initialized now. And they should have obstacles. Okay, I think we can do the planner now. The planner. Okay. Nodes, we have a node source and a node destination. So if we just do a quick Googles, algorithm. It's random people. See if you do this and da ba da ba da ba da ba. I think I looked at this one before. Adjacency matrix. SPT set. Well, true if vertex I is included in shortest path tree or shortest distance from source to I is finalized. That sentence doesn't quite make sense. It's just the index of the... I'm not following his algorithm very well. Lecture 9. Give me some pseudocode. Pseudocode's always good. Wow, what is this? Why is it so big? Does it remember like I zoomed in previously? Is Google that good? Interesting. So it basically does an iterative process to generate the values for each vertice. And then after it's done that, it constructs the shortest path with a stack. Going in reverse order. Code for Dijkstra's algorithm. In C++, like a boss. Ford Fulkerson's algorithm? Don't know what that is. Let's see. Path. think I can make this work. So this, for each node in the graph, set the node's distance to infinity. So if I go to here, I'm doing that already. Their distance. And their parent to none. They got to no parent. Let me just make sure. Maybe this is what's confusing me. So I can. It's not how you rename. Jesus. Rename. Control R. Oh, jeez. Distance. Oh, jeez. Okay, so control. The. Apparently the command shortcut or control shortcut just isn't not working. So control R. What? Make no sense. We didn't like the variable. Okay. Distance. So that's essentially what we're doing here. So we're already doing that. I do not create an unexplored set. I'm questioning whether or not that's useful. So, can you do a for each over 2D? C# for each on a 2D array. Is it a thing? That's not useful. Okay, so it will do that. Like it's not a 2D array. Okay, cool. We're gonna do that. So yeah, we would just want to do each node in nodes. Oh, that's not what I wanted. It's just to save, not to save, but to verify. So we would set the parent node to null and set distance to the max value. So that's essentially this. I'll find it. That's this first part. I'm just gonna. This is usually how I implement things that people say are how you do something. You just like copy that shit in and call it a day. And then from here you can do this. Because actually, let's do this. I think it came in. Because then you kind of have a pseudocode, you can follow it along a good bit easier. So then it's like, okay, create an unexplored set. And then then it looks like you get the current node, which is not happy with the formatting, which is fine. Interesting. This is not ideal, though. Like, we need an efficient way to look up the current node with the smallest distance. The brute force way is to iterate over all the nodes. Find the one with the smallest distance. Check completed. So we need to be able to look up. So this unexplored set is very ambiguous, and to make these other functions efficient, it looks like you have to at least have a couple things. One is you need to be able to look up in that particular set. You need a way to be able to look up if it's A in the set and has the smallest distance. So it's like a sorted set. So that's the first requirement, is like it could be a sorted set, something like that. I don't know. The next thing is check if it's the goal. That's fine. That's easy. For each neighbor, you need to be able to check to see if that neighbor be able to check if neighbor is still in set. It's like the easiest way to do this is actually just to set a flag on the nodes of visited or not visited. I'm gonna do that. I don't really care. Because then you don't have to look up anything. So and we can actually reset that here. So node dot can I just make that accessible? Can I just do this? All right, so that is just a way to basically set that it's visited or not visited. Visited. The only tricky part there it's hard to tell if you're done. Because you don't have a full picture Ugh, that's why. So we can check to see if it's still in the set by using the flag. But if it's still in the set after we visit it, we need to remove it from the set. How is the new distance ever better? Interesting. This is kind of hard to see how this will resolve in a world where we're just using it for 2D path planning, where it's a 2D grid. Because the initial cost is 0, or the initial distance is 0. So, like if you walk through the pseudocode, so basically, start with all the nodes while the unexplored set is not empty, get the current node. Alright, so we get the current node with the smallest distance. That's the source, because that's where we start. Remove that from the unexplored set. If you're, it's obviously not the goal, it's where we're starting. And then for every neighbor, which is all the nodes around us, so there's 4, assuming there's a cost of 1 to move to each one of those, which is fine. So let new distance equal current node's distance plus distance between the current node and the neighbor. So that would be 0 plus 1, and so every one of those would be a cost of 1, essentially. And then check to see if the new distance is better. If new distance is less than the current node's distance, set neighbor's distance to new distance. And so like that doesn't resolve in the case that the cost is all the current node's distance is always 0. It starts as 0. Is this correct? I don't know if I follow his algorithm. Let's see if we can get some consensus on this. Because in his algorithm, it's basically saying we calculate the new distance, and only if the new distance is less than the current node's distance do we set the neighbor's distance to the new distance. I don't think that's correct. I think that is incorrect. Jesus Christ, he did handwritten garbage. Oh, that's like the worst. Do. Dijkstra's magic. Take a look at this guy. Is this the one that I had earlier? No, this is a different one. This is a different dude that did the same. I think this may be the same thing, but actually path planning. So this one is just the Dijkstra's algorithm. This is actually using the path planning side of things. Okay, so no parent. Find the shortest path for all vertices. So nearest vertex. Pick the minimum distance vortex. Vertex from the set of vertices not yet processed. Nearest vertex is always equal to the start node in the burst the end vertices. Parent rate is store shortest path trees. Where? Okay, so it's the X. Update the dist value of the adjacent vertices of the picked vertex. This is just super complicated. I don't... And the reason is that they have... I guess it's not super complicated. The reason... It's unnecessarily complicated. That's a better way to put it. Because of the fact that we don't have... We have a uniform cost. So... Let's take a look. This is the guy's... oops. This is the guy that I snagged some amount of code from. So he starts at... Start just to transform? Yeah. He sets the weight to 0. That's fine. So he does use an unexplored. That has everything. Has all of them in it, which is fine. Oh, and he only adds walkable ones. Oh, that's a good idea. Good call, my man. It's unexplored. Does he sort these? Where does he sort these? Ah. There. So he removes the node, then he gets the neighbors. Yeah. Get neighbor node, and it returns a list. Wah wah. So it gets the distance. Yeah. Takes the current node's weight, has a distance. The distance is less than the current node's weight. Ah, that's the disconnect. So it's not the current node. Or it is, but damn, that's confusing. They could have used... So it is the current, it's the current neighbor node, not the current node. So that's where this explanation... Where did he go? Did I get rid of it? Oh, now I feel bad. So this is technically true, but it's also not. So current node in my mind, when I look at this, is the current node of the unexplored set. But the current node down here is the current neighbor node. So it should always set this. This is almost always never, this is almost never gonna be false. Because the new distance should always be less than the infinite distance that we set when we initially set it up. That's all this is checking. So we set this max value, we calculate a distance, and then we set it as long as it's, you know, less. Because I'm like, how does it, this doesn't make any damn sense. I'm like, how are you going to take the current node's distance and add to it? When in the hell is that ever going to be less than the current node's distance? So, this is technically correct, just slightly different. The verbiage is terrible. You should have given this a different name. So like for neighbor, you know, neighbor node. And then you say, if the new distance is less than the neighbor node's distance, set the neighbor's distance to new dist. And set the neighbor's parent to current node. Although this might be, that might be wrong. But anyways, let's do a couple things. So first things, boom, 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 boom. One thing that I like that I picked off of one of those other things is if it is an obstacle. Boom, 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 and boom, and if it's not an obstacle, then we add it. Cool. Okay. So then if we follow this logic again, so we create an unexplored set, which I think we can get away with explored nodes equals and then while unexplored nodes is it an empty? The hell? Is it not did he not use a it is a list, right? It is a freaking list. Wait, no. Did he not use a list? He did. Oh, so he did the count. Okay. Well, I thought there was a cooler way to do this. I thought there was gonna be a is empty. I think there is for an array list or something, and maybe that's Java. So as I mentioned earlier, basically sort by distance. So what we can do is do a sort I could go look at this guy's code. It's basically this. I can never remember this format of things. It's like you would have to Yeah, it's the comparisons, system comparison. And then we would basically get the current node equals unexplored nodes. We pull the top one, that'll be the lowest, you know, distance. So that's how we can do that lookup. And then we remove it. Wonder how smart it is about looking those up. All right, I'm gonna go ahead and put this code up here. So I need to know if current node dot equals, what is it equals? Check. It's an object equals. Ugh. Ugh. This may not be correct. Yeah. So the starting node so he's basically doing what I need to do. So you set the starting node to wait. So source dot set distance to 0. And you iterate over them. What's he do when he finds him? Oh, just as a blanket. Interesting. I don't think I have a return value for this, right? Yeah. So we're just gonna return. Okay. Now it's for each node neighbor in current node dot get neighbors. Oh man, I just made fun of this guy for making this not plural. Okay. Really? Where do I use neighbor? Oh, maybe it's complaining about this. Yeah. Classic. Okay. So all right. Do. Calculate the distance. So we get the current, the distance will be a float, right? New distance equals current node dot get distance plus 1. Is his more sophisticated than that? This is surprising. Why does he need this when he filtered it out here? Oh, because his neighbor nodes haven't been filtered. Interesting. Interesting. I wonder if this guy had more than just horizontal and vertical movement. That may be a reason. Hey, Grandma. Thanks for the like. Appreciate it. Hope you're having a good night. I think this is just general purpose. That's what I'm gonna chalk it up to there. So, check for existence in unexplored set, right? So if unexplored dot contains, dang it. See, I'm technically filtering my neighbors. Maybe I shouldn't though. In the path planner, I am ignoring neighbors that but I still add the nodes that are obstacles. I'm trying to think of the equivalent of what he's doing. So he, when populating the unexplored, he filters them, which that takes care of. Should take care of this. I don't think I need visited anymore, but that's fine. So there's two things, right? There's the node itself on whether it is an obstacle or not, and then each node has its adjacent nodes, and then whether or not those are obstacles. So the first check here, this, if the node dot is so if it's not an obstacle, then I want to add it to my list as an unexplored node. So that takes care of the main node itself. But then each node itself, assuming technically this takes care of preventing obstacles in the planning. But part of me questions whether or not we should do this here. This is potentially eliminating information that other planners could use, so I'm going to take it out. Okay. So now every adjacent node is included, even if it's an obstacle. And what that means is down here, when we actually check the neighbors, it has to be both contained and not an obstacle. Okay. So in that case, and I think that's what he does here, right? He checks to see if it's unexplored, it's contained, and it's walkable, which is fine. He calculates the distance. I don't think we need to do that. This should actually be in here. So first we calculate the new distance, which for us is just the current node's distance plus 1 in all directions. Then we just check to see if the new distance is less than the neighbor get distance, right? And if it is, in that case, and why did it? C# is so finicky on when it formats for me and when it doesn't. It's like if I put a curly bracket on the top line and then I go to the next line and do the curly bracket, it doesn't fix it. But if I do both curly brackets and then hit enter, it automatically formats it. I don't. That just doesn't make any sense. So then we hit the neighbor set distance to be new distance. Okay. I mean, that's what I would expect as well. So then we would just we'd set the parent node to be, oh, that's wrong. Parent node. Why is it a transform? Whoops. I forgot to update this. All right. Forgot to change that to node. And then this would be current node. Interestingly enough, okay. Something to note that's interesting is the neighbor nodes are not removed from the unexplored set as part of this loop. And at first I thought that was a problem, but when you think about it, what it actually does, it evaluates every neighbor from all directions in order to make sure that you get the shortest distance. In the case, like, you could imagine, I'm trying to think what a good example would be, but could imagine where, like, you know, there's an obstacle in the middle. You start on one side, and your goal is on the other side. So it's just like a 3x3 grid, right? So Actually, I could probably type this out real quick. So imagine you have, you know, let's do 1, and this is your goal. The X is an obstacle. So in this case, and these are costs of transitioning. So like, ideally, you would want to go this way, right? You'd go left, and it would only cost you 3 to get to the goal. While if you went right, it would cost you 6. But I'm trying to, actually, this isn't even a good example. Let's do this. This is a better example. Something like this, maybe? It's when you have neighbors that are neighbors to multiple things. So like, for example, when we evaluate this node, we're going to look at its neighbors, which are this one on the bottom, this one here, and this one here. And what's going to happen is when we evaluate this one, its cost at this point is 6. And so the cost to get here from this node would be 7, because you have to pay the 6 plus the 1. And so if we're evaluating it from this one and looking at its parents, or at its adjacent nodes, then this one's cost would be 7. So let's just say we evaluated this path first. And so we'd set the distance, like we're doing here, for this node to be 7 on this neighbor node. Then we go trucking through the rest of the grid, and then we evaluate here, and we look at its adjacent nodes. And this one's cost currently is 3. And then we look at this, and its new cost for this node is 4. So you actually, like, when we evaluated this path over here, we can't remove this from the unexplored set because we still want to evaluate it as part of this particular evaluation as well. So, because then what would happen is we calculate the cost of this to be 4 in this case, and so we'd set that to 4, and we set the parent node for this to be this one. And so that would be the lowest cost. So what you can essentially do is, you know, track the parent nodes using, and then the parent nodes are essentially giving me the path. So we should be able to just say from the start point, actually from the end point, find the parent node, find the parent node, find the parent node, and eventually it'll get us back to the goal, or to the start. It's actually reversed. Okay, so I think this is functioning, and we can go from there. I don't think I need all this. I think we can do this because ideally they're the same memory address location. We should be. They're the same object. Okay, so I'm gonna try this. I gotta see how long that shit took, took to take. How long that shit took to run. I think this dude did something similar, right? So he did a little, like, give me real time. And then you can calculate at the end, just basically just give me the seemed like it took a long time though. Did I save that? It is taking a long ass time. Look at this. It's like several seconds. How is it taking this long to... Some stupidly inefficient shit going on right now, I think. It's probably that sort. Did I save it? Ah, jeez. I did. Okay. It's just taking that long. Wait, what? What the hell? Oh. It's because I didn't focus the game? That's weird as shit. Okay, whatever. Oh no, it's because I have to click somewhere. That's why. So let's see. So there should be do. Let's do this. I'm actually gonna extract this into a separate function. Then, is that that? Is that it? Yeah. Dang it. Let's do execute. Whatever. Static? What the hell? What? A static? Let's not do that. Okay. Okay. So what I'm interested in is figuring out the path that actually gets planned. So what I do want to do is do like if input dot get mouse button, 1. clicked. I want to be able to kind of figure out what the path is. So what we can do is find the path and then print the path. So while we'll do node parent node equals des.parent node. Oh god. Did like 15 of those. Just do that for right now. And then we can do parent node equals like that, maybe? Maybe? Oh, we'll figure it out. Okay. So theoretically, sweet Jesus. Why did it print that 7 kajillion times? Sweet baby Jesus. Ah. That's important. Start that over. Jeez. Don't get a full dump here. Okay, so he is at 0, 0, 0. I'm gonna go to 2, 0, 0. Fair enough. All right, so in that case, it didn't print the destination. Jeez. Ideally, you would push these onto a queue. Or, nope, push them on a stack. You put the destination in there. So, actually, do they have stacks? Because that would be... Yeah, I surely hope they'd have stack. Can I initialize it to capacity? Nope, I have no idea. So we do planned path dot push, and we would push the destination, and then we would do parent node. So yeah, one An easier option is just to look at the stack. Yeah. So why are you mad? Oh, it's because it's running. Okay. So simple case would be just like right here. Don't care about the return. The stack, the planned path, has 5. So we'd go from 0, 0, which is a restart, to 0, 1. So we'd go up 1. We'd go over 1. Over 2. Up 2. Okay, seems reasonable. Right, that's right. I clicked 1, 2, 1, 2 right here. So it went up 1, up over 1, over 1. It basically did like this, which is pretty fine. There's a good way for me to draw this. Looks like the borders are drawn on top. So I might get away with just drawing the path. Let's do that. Let's do a stack of notes. Nope, 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 nope. And nope, nope, nope. Okay, so then this should have what we can have is current planned path. That is the stack of paths, no, nodes. Wonder how mad it's gonna be if I just like pop those off. All right, so if a planned path not equal null and do that. Oh, man, I gotta do all these translations. No fun. So let's see. So for each, can you for each on a stack? I'm gonna try. Very surprised. What? You can for each a stack? What the f... I don't understand how that works. Whatevs, but you know. Okay, so what we need to do is node start. So if start equals null, then we set start equal to location and continue. And then is that better? There you go. And if it's not equal to start, then what you do is debug.draw line vector3 duration. What the hell? Whatever. I don't even. What does duration even mean in the concept of a draw line? But sure. Okay, so it would be start grid location. So that grid location is actually Jesus. Okay, that is legit local grid location, which needs to be converted to, let me see if I can just create a function that does this for me, because I have to do a lot of conversion. Not too much conversion. Let's see. I think the player movement is the closest thing. So it has a vector3, which is sprite compensation, which is the cell side divided by 2. This is the closest thing that has to do drawing. Because it takes the current location. It does the opposite, basically. It does a current location, converts that world location to a cell location, which is actually world-based cell location, compensates and then converts it back. Ugh. All right. So I need to do, it needs to have access to the world grid. Oh gosh, all this fluff for, might be worth putting this in some kind of generic class or something. Oh, I already have it. What? Okay, cool. I already have the world grid at least. I don't have the cell size or the sprite compensation. Sprite compensation just lets me know where to, how far to move to put it in the center, essentially. Okay, so in this case, all right, I've got, so I'm gonna just create a private void node location to center, world center location. I don't even know how the hell that's like super confusing, but It's all good. Let's go with that. And so, actually, let's do a vector3 int, which will be the grid location, which is the world grid location. Okay. So let's do this. Start dot grid location. Then node location. I'm gonna go ahead and put this in. This needs to return a vector 3. So we set that, and then we set the start equal to the location. I think that's right. A better way to do this is not equal to null. Then we do this. Then you have to, then all you have to do is that. You don't have to do that in 2 different places. All right, so we have a world grid, right? That's trying to remember. This is the most difficult part, is trying to remember the grid, like whether or not the grid location's in world grid or a local grid, and then how to compensate. So local grid is not useful because that's just for looking up. This is where the local grids are, so it might be. Let's do something real quick just to make sure. Okay, so it is 0, 0, which means it is world grid. So in movement case, how did we would normally take so that's what we would take cell to world. So we would do world grid, cell to local. Then we would add the offset, so sprite compensation. Like that. I think that's right. We'll find out real quick when I click in the thing. Holy shit, it worked. Y'all can barely see that shit, but it does actually work. Can you see it over here? Yeah, you can. So so these flowers are obstacles right now. So can you make it thicker? Sit here. Duration. Oh shit, you can tell how long. Okay. Alright, well. Maybe hard to see, but it's working. You can see it when I move this around. Let's see if I click over here. Oh, I gotta click over on this side. See, it finds that path. I click. Just straight up, that's fine. Boop. Usually takes 200 and... What about? It's like this spot over here probably takes the longest. Yeah, so that takes almost half a second. 0.4 seconds, roughly, to calculate this. And that's basically because it has to explore the entire thing. Same with probably this corner way back in the bottom down here. Yeah, so this one actually longer, 0.55. And this is a tiny ass little grid. Could you imagine trying to plan this in like a much bigger configuration space? What is this, like 7,000? Wait, see. So it's like 74 by 46, 3,400 configurations that it has to explore. Like when you click in the absolute corner, it has to basically look at, you know, 3,400, probably more than that actually, because every single one of them, it looks at the neighbors and calculates something. So, you know, if you, this is way more than expected, but like 13,000 nodes still doesn't seem like a lot, right? Like a computer should be able to calculate that junk real quick, like. But there's probably some inefficiencies in here as well. Okay, so that's, I do want to figure out a better way to visualize this on screen, because this line is garbage. Kind of want to do something like as it computes. Like, is there a good example? Maybe this. Oh, that's not good. Let's do this one. Does this one have a... Yeah, kind of like this. Sorry, if you can see it, it's this. So it kind of shows you how it's planning. Same with this one. What the? That's cool. What is that one? Oh, that is the... it's significantly slowed down. What they tend to do in this case is like, oh, well, let's put a delay between every step and then we render it, because otherwise we're just going to and it'd be done. The interesting part, though, it's like this one's doing diagonals as well. We're only doing like X and Y. Could you imagine if we did other directions? That shit would be slow as hell. But I think that shows like this is extremely inefficient. Right. So if like I feel like there's a better way to do that. This is essentially sorting all 3,000 nodes every time we look at one node. That's terrible. This lookup is probably super inefficient because it's just using a node object, so it probably like computes a bunch of the different fields and compares them before it knows for sure. Same with this potentially. Do they have like a sorted list actually? They do. A sorted set, which is even better. But how do you define sorted list? I was gonna say, how do you define the sortedness of a particular class? It uses its own custom comparator. Wonder if we can get away with this. Just a sec. So if we make this a, let's say, sorted set, for example. How is it okay with this? How the hell is it? No. Okay. Okay. So what we need is something like this. But specifically for a node. So this would be a by distance. So I guess this would be something like that. mine's way way more simplified than theirs. It's crazy nonsense. And then they should be able to do what, like new by distance. We shouldn't have to do that. Oh, shoot. Oh, what? You can just do min? What if you want max? Can you get max? Okay. I was like, what? Oh, God. Alright, let's see if this speeds it up at all. Kind of curious. So it's like a little over half a second in the corner before. Let's make sure I saved. Yep. Start this thing. One thing's for sure, I broke it. I have a feeling it's the set, because I don't have a good. Wait, what? Maybe it's because, what do you need to use a set? It's probably hash. No, that's Java. C# class. Index. Boom, barrel, barrel. All right, let me. I'm gonna dig in, figure out why. Uh, hmm. Let's see what happens here. My assumption was that the nodes are getting lost, but maybe I'm wrong? I am correct. All right. Hey, Chris. Thanks for the like. Appreciate it. Hope you're having a good night. So yeah, the I think it has to have a defined lookup. Use custom class in set C#. So yeah, for some reason the two different yeah, so it's the equals and the hash code functions. Yeah, so it's thinking the two different versions or two different grid locations of the same thing. So in here, in Node, I basically have to implement a couple things. Basically, is hash and is equal. Hey, look. Pigment's unit grid location, I think, is all we need. Well, that was easy. Now, where did it put these? Where the hell did I get that number? 111-724-1146. Okay, cool. All right, so I think this will work. Let's go ahead and I'm just gonna run it and we're gonna see if it fixed the problem. Cause it'll be quick. Did not fix the problem. Let me double check and make sure I saved it. Okay. Now let's attach and make sure that it's still the same problem. So we click here, we initialize the set, there's no nodes, we add one node. Like what? Some reason it is not. So the current node in there's grid location is -37, -23. The current node that we're trying to add is -37, -21. And it doesn't think that's sufficient. That's some weird syntax right there. That's how you can cast an object, I guess. So it's checking to see, is the passed in object a node? And if it is, it casts it to a node and gives it a variable name. And then I can use that later on in the function. That's kind of crazy. All right, I'm gonna go off the deep end here. And we're gonna generate it for every single field. It's gonna be this huge dump. Yeah, like this seems excessive. But let's at least see if that. Yeah, so I'm starting to question whether or not the set is the is the way to go here. I am kind of curious why, when I ran it the first time, or when I do a list, right, a list uses a comparable underneath, so why the hell does that work? And it's all fine and dandy. Wait, where was I? Was it in here? Extra planner. So lists under the covers. They use the same thing. So like it has a contains. It expects the items to have some level of maybe that's it. Okay, maybe there's one piece of information that I'm missing. Let's go back to the node. If I just check all the stuffs, and it generates even more ridiculous stuff. Oh, it generates a separate method? Okay, whatever. And generates static operators. What the hell? I just don't think that is... Yeah, no. Okay. We gotta get this back to working before I get off tonight. So I am... Okay, so sorted set, not so good. Sorted list, maybe? What? There's keys? That's a sorted dictionary. Why do they have a... Like, what's sorted list versus sorted dictionary? Ah. Okay. Interesting. So it's just the backing data structure that's different. Hmm. Enumerable. Do I have to... No? Hmm. Alright, let's try the sorted list, which will take a vector 3 int node. I don't really like this though. Yeah. Oh, I think I know why the set doesn't work. So the comparer itself that's bonkers. That's why. It uses the comparer to know, like if it's 0, it uses it both for sorting as well as quality comparisons. Jesus. All right, I think I'm gonna do this here. Okay. So sorted set takes so really it's if x dot grid I think 0 is equivalent, otherwise I'm trying to think of how this would still be whack. So 0 is equal. Alright, let's see if this is it. Negative. Negative. Alright, my quick. Oh, I'm just gonna change this to use a sort blah blah. Did not work out. So switching back and let's just verify this works. Winner. That's what happens when it can't find a path. If you it takes 2.5 seconds. It's like, whoa, wait, what? Okay. Cool. I think that's good progress for tonight. We made significant progress. Yeah, and I think I want to work on a better way of visualizing that so that we can do the other planners and actually see a difference, because right now it's just like, oh, look at the line, and you can barely even see it. It'd be better if we could color a square over the top or something. So I'll try that next time, as well as maybe we try to speed this up a little bit. That's always fun. Optimization. Cool. I'm probably gonna play a game of Apex real quick so I can get my treasure pack. Treasure pack. That's how they get me. No. Not a single person's playing Apex right now. I also can't play too much because my finger's all jacked up. So we will limit this time. Is there audio? There it is. Like, I didn't hear anything. I just saw flashing lights. Bow, bow, bow. Loading. Loading. Oh, a new hunt's available. See if old Camster wants to join in on this fun. Oh man, that's the good stuff right there. Let's see if I can get just yoink him with a random invite. While I wait for that, nope. Play 2 games as Rev. The Revster. Easy. Nobody wants to play. What's up? Maybe? Are you there? Can you hear me? Can I just not hear you? Hello? Hello? I hear nothing. I see no light. Wait, there's a light. Just can't hear you. Can you hear me now? Hello? Still nothing. I blame voice meter. It's almost always voice meter's fault.
Good luck, brothers.
Wait, what the?
I'm Jumpmaster. Follow me or stay out of my way.
I don't know if you're just bad or an idiot. Either way, you're gone.
I still can't hear you. They brought back World's Edge, bro. What the hell? Well, we're just gonna go for this. Did you say something? Maybe it's a dude in my game? I don't know. No freaking gun.
Shot a cargo body. Bam! Here goes the boozle. Something like that.
Yo. Still can't hear you.
Found a body shield here. Level 1.
Ugh.
I got a vault key.
Skeptics are here.
Reloading. Here to save the day. I got everything under control.
Still nothing.
Okay, that must just have been the last one, because no one's revenging or whatever.
Hope you're not expecting a thank you. Healing.
Recharging shields. Backpack here. Level 2. Body shield here. Level 3. Shield battery here.
Healing. Longo DMR here.
Still can't hear you, Cameron.
Standard stock here. Level 3.
New kill leader appointed.
New kill leader. They're next on my list.
Hey, looking for sniper ammo? 1 minute until close. Rings nearby.
There's sniper ammo here.
Champion has been eliminated.
Not much of a champion now, were they?
I got a vault key here if you want to carry it. Rings close. 45 seconds.
I have a vault key.
I need a shotgun bolt.
There's sniper ammo here.
30 seconds. Rings close.
Shotgun bolt here. Level 1. Extended light
Evo
mag
shield
here.
here.
Level
Level
2. Get in the ring or I'll kill you myself.
I was just here for this dude's amusement, apparently. These are all the heavy lifting. I just kind of walked around a corner, got mastered to the face, and ran away.
Got a sentinel here. I need a hop up. Skull piercer. How about this way?
I heard you.
Care package being
Still there, Cameron?
Care package out.
Okay,
Someone's
okay.
been digging around over there.
I heard you.
There's one, right here.
I heard you.
Bam to the woozle, sending out a decoy.
He said he saw someone. I don't see Jack.
Bam to the bam. I'm running out of ideas. ideas.
Vault opened. Found a body shield here. Level 4. Shotgun. Found a hop up here. Skull piercer. I like the sound of that.
Bam to the woozle. Sending out a decoy. Bad guy over there.
Saw someone over here. Someone's out there.
Round 2. Beginning ring countdown.
Next ring's far.
Taking him out with a decoy.
Skin suit over there.
What this dude's plan is here.
Someone's out
It's
there.
Wraith up top. Just jumped off. Coming to this building.
Bad guy over there. Getting shot at.
Wait, what?
Giving my shields a recharge. Bam, there goes a boozle. She got
Broke behind the
bamboozled.
truck.
Just gotta patch myself up. Bam to the woozle. Yeah, sending out a decoy. Kids, the ring's closing in 1 minute. You got bamboozled. Look at this.
Taking fire. Rings far. 40. Recharging shield.
Got one here. Recharging shields. Come on, bamboozle 'em.
Shields are low. Recharging.
You got bamboozled. Shots fired, and they're hitting me. Giving my shields a recharge. Sending out my decoy. 1 sec, healing up.
Get over here.
Yeah, I think this place needs a little more me. I just gotta patch myself up. Hang on.
Attention. There is a new kill leader.
There's a new kill leader, and it isn't me.
Faking him out with a decoy.
Attention.
Get bamboozled.
Just gotta patch myself up.
Care package coming down.
Down one.
That one's down.
Jeez.
I need some loot. Check in here. Decoy escape.
The skill takes experience.
Oh, let's see. Ba-ba-bum, ba-dum-bum. See where he's at. Is he hanging out in some random? Nope. Maybe he texts me. Yeah, got him. More game for this guy, and then I'll do the hunt. The camera's playing with some friends, so.
The only thing that matters is body count.
Our path is made today.
This is your champion.
Can't believe we got beat by that team. That team was garbage. With how that dude performed initially. Oh, let me change this over to Apex. There we go. When we initially had, I assumed he was gonna wreck some people, but then he started playing like me. I just now gave it up. Okay. I don't even care. You're going over here, bro. Because I'm actually going to go into the hole. No squads? There's no squads going? What? Okay, there's one. Then there's this guy. Landing in this freaking place as me. Leaving me a mastiff, bro. You left me a mastiff. Got a purple armor? A shotgun? Oh, no. Got a 2x. 2x for a freaking mastiff. Wanting to push this.
All Father, keep hostile close.
Someone's got a death wish.
Wow.
Pick me up.
Would he laser me with a... Just unbelievable, like... Lasered me with that 301. Hey, watch this, dude. He just demolished me. dude looks like a Call of Duty player. Full of jumping. Ba-doom, ba-doom, ba-doom.
Barrel stabilizer here. Level 4.
Let's get into a fight, my friends. I want to see. Oh, come on. What's this? Did like 140 something damage with that Hemlock through the two. In between two boxes where all I could see was his noggin. That's what I get for using a Mastiff. I called it. Actually, I didn't call it.
Care package being delivered.
Man, this is boring as shit. They've barely even gotten out of freaking refinery right now. Just run into somebody, please. I just want to see if I'm just terrible. Just kidding. You guys just like started playing yesterday? Both level 20s with, I mean, this dude has 11 kills. That's not anything special. This dude has 55 kills. Oh my god. This buddy boy went AWOL. You hear the footsteps. Are they going to get demolished? Wow. That was absolutely sad. Waste of my time. Okay. Let's do this thing. I'm waiting. I'm matchmaking for a solo thing. Explain that shit. See if I can not get demolished by these ravaged beasts. No. Oh wow. Crap. Gibby.
Ready to go.
Do we all have the same? Yeah, we do.
I didn't ask to be the best. I worked for it.
Is it so much work to make you not have to wait for this? They can drop me on the top of this tower? Freaking sweet.
There's the piece. Hey, just like a rescue.
Hopefully those things. Oh, they can't open doors. I want a better gun. Ooh. Oh, snap. Huh. Supposed to be a crate out here.
Giving my shields a recharge.
So slow. Oh, for some reason.
I'm bleeding out. Somebody has to lose. That's just how this works.
Oh, committed. Oh, committed. Decisions. There's a chance I could find an R9 down there. I'd rather take the bolt.
Recharging shield.
For some reason I didn't make the connection that those are red and therefore do damage to me. Ooh, I think I will. Where you at? Where you at, son? That art. Ooh, I'll take that. Wait, a Spitfire? Oh, never mind. Not excited. Not as excited about this. On my face. I'll take this 301. Don't mind if I do. Where you at? Oh, am I gonna get it? Oh! Get my face.
Hey, grab the piece. Better get back to safe round.
Dodged. Gotcha, sucker. Eight. Classic Peacekeeper. Get him. Knocked him. Getting him. Bippity boppity boo. Got the artifact. Artifact. Now what? I wait another week. Who would fail? Oh yeah. Sharo Machi? Ah. Excuse me. Oh god. Man. Like, I accidentally, like, it, like, double clicks. Wow! I skipped something. Interesting. Interesting. Okay. 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 Interesting. How many? Man, this is gonna take how long? 20 days, 27, 34. This is a solid, like, 2 months. I'm gonna be playing this for 2 months? Well, there you have it. There you have it. I gotta win a ranked. Oh, God. Well, that's where I called it for tonight. Ba-ba-ba-ba-ba-ba. Alright. Ba-ba-ba. That's it for me for tonight. Let me switch to. So yeah, that's it for tonight. I'm gonna head to bed. But yeah. Tomorrow? Yes, it is tomorrow. Tomorrow we will try to figure out a better way to do like visual indicators of the planned path, and then from there we will figure out how to maybe try to optimize it a little bit. See. And is half a second to plan across that tiny little space seems like a lot. And I think I identified the few things that are causing significant slowdown, which is the sorting every iteration, and then some of the lookups that we're doing in the array, or what is currently a list. So if we can speed things up by taking up more space in memory, so we can just hold on to a list of maybe vector 3s instead of whole objects, and then we use that to actually do the lookups. That could potentially speed it up. Trying to think what else there could be. Yeah. Anyways, there's ways we can speed it up, I think. So maybe once we figure out a good way to visualize the path tomorrow, we'll look into optimizing a little bit. And if we get done with that, then I'll probably play some games, but we may look into doing some other path planners as well. There's we've done Dijkstra's, which is pretty straightforward. It just assumes a cost of moving to one location. Another one would be to do greedy first, I think. Greedy best first search, which uses the distance from the current location or the node to the final destination. So, and then minimizes that. So that one should plan a lot faster, but take non-optimal paths when obstacles are involved. So we may be able to implement that as well. It's generally Dijkstra's, but with slightly different cost function or distance calculation. So, but yeah, join me tomorrow for some of that stuff, and I will have a good night, and I will see you tomorrow. Enjoy the rest of your night.